between them, but it creates ammonium chloride.
Good morning, everybody.
And
welcome to the science track room. We got a few more minutes before we get started, but I want to cover some base rules real quick, everything else. For the panel this morning, make sure your phones are on, vibrate or silent. Just a common courtesy for the panelists, everyone else on the stage. Second, please have your mask on over your nose, over your nose and chin the whole time of the panel. Sorry to take a sip of water, but we do ask you again just to make sure that everyone's COVID safe here. A couple things coming up. You are in the Please Don't Lick the Science panel. If you're not here for that, well, too late, you're here. Coming up later on today, after this panel's over, is some bigger stuff, mRNA and vaccine platforms in the Crystal Ballroom. Do we need to kill all the mosquitoes? That's the Crystal Ballroom as well. And then the big panel for tonight, Science versus Movies, where we get poor scientists defend bad science in movies. It's wonderful to see them suffer like that. It's not necessarily, but if you have any spare change or donation at the end of the panel, if you could, we're raising for Big Brothers Big Sisters of Atlanta. Every dollar that you donate will be matched by Dragon Con, I think up to $100,000. So help us make them pay. It'd be wonderful. Anyway, I think that's about it.
All right. We still got like 4 more minutes. Is this on? I don't think it's on actually. Yeah, I'm like basic. Okay, so I just had to like basically touch it.
Test.
Y'all are welcome to take the microphone off, but hold it if you want to. That might be easier for it to either way.
I feel like if I try and take it off, that's going to
Donk.
lead to some comedy.
Hello.
Unintentional comedy.
Where we like let it go and it goes around.
Yeah, or I like gesture and I take out the entire panel and it's very
Excellent.
short.
Please don't throw the mic.
All right, folks.
But if you do, make it worth it.
Okay. I'll try and go for like first goal, like bowling.
Samples, exciting.
People like to see if you look at things, I guess. If you have an empty seat next to you, please raise your hand. Anyone that has a raised hand has an empty seat next to it. All right, thank you much. Yes? Yeah. We can move it down a little bit. And then all the Lysol cleaning products.
This panel is not closed for cleaning. It's not the hottest new panel of the Dragon Con
Man,
2021.
it's like sweeping all fandoms.
Spreading like the, well, you know.
Too soon.
Because juices are chaotic, and so is science. No, juices. Have you played juice game? Untitled, yeah.
Last year during the digital Dragon Con on Discord, there was a screaming rainbow goose emote, and the science panel participants used it vigorously all over Discord, and I believe that's why it ended up on the badge this year.
Now we have a rainbow knife goose, so join us on DragonCon official Discord. We have geese.
I believe the name of that emoji is Science Goose.
It's actually Science Honk.
Science Honk. Just in case you wondered what the track was like. It's rainbow geese with knives. Yeah.
Honk or hyonk?
I should switch it to Hyonk right now.
All right, looks like we're about ready to get started. Hello, everyone. Welcome to Don't Lick the Science, the track where we're going to learn to make good life choices.
Unlike the choices you made last night.
And with that, I am Celia Yost. I am your moderator, and I'm going to let the panelists introduce themselves.
Hi there, I'm Nick Householder. I'm an aerospace engineer. I did a couple of seasons on a Science Channel show called Street Science, and I also design and build the science demonstrations for The Tonight Show. Today, I run a digital media company called Midnight Science Club, and we do cool science demonstrations on the internet. So check us out everywhere.
Hi, I am Emily Finke. I am by training a forensic anthropologist, so I'm actually not allowed to lick much of my science. I actually spend most of my time doing science communication, so track me down and I'll tell you about whatever interesting, weird fact I've just learned. I'm Celix on the internet.
I am Tori Stenmark. I am an organic chemist and I associate faculty at Shoreline Community College near Seattle, Washington. You should probably not lick most of organic chemistry. Most of it. There are exceptions.
And I'm Scott Harris. I'm the planetary geologist for Fernbank Science Center and the Jim Cherry Planetarium about 3 miles down the road here. And I deal mostly with asteroids and comets hitting things, but I'm also a crystallographer and mineralogist. And so we are one of those weird sciences that actually has textbooks that encourage you to lick things.
Yeah, lick the rocks, figure out what's in it.
Okay, well, with that, I have a very important question for our panelists. Why the heck would I want to lick any science? Because, ew.
Should our geologist start with that?
Well, I will start with, as you hopefully know, it's not advisable, but like I said, we have actually textbooks that say, hey, distinguish this mineral from that mineral by tasting it. And so one of the obvious ones, hopefully, is a little mineral called halite that you know is table salt. And you might say, well, if I kind of look at it and know it's salt, why do I need to lick it? Well, there are other salts, plenty of other salts, as my chemist friends will tell you. And that one that uses table salt kind of tastes particularly good to most people, and the other ones typically don't. The ones that in the field we deal with mostly is something called sylvite, which is potassium chloride as opposed to sodium chloride, and it tastes pretty bitter. So if you want to do that, that's fine, and there are better ways to distinguish those, though.
Can you describe at all what it's like to taste those various salts? Is there any comparable other things that you've tasted that taste similar?
Dirt. I mean, that honestly, we all know what table salt tastes like. And sylvite basically tastes like a sort of a stale soda. Maybe. And everything else pretty much tastes like dirt. But of course, geologists also, we don't just lick things, we actually sometimes eat them too. Like to tell the difference between, say, a clay stone and a siltstone, which is like a few microns difference in size. So you need a pretty powerful microscope which isn't available when you're out in the field. So you actually just take your tongue out and lick it, and if it's a little grittier than not, then it's a siltstone rather than the clay stone.
I actually love this. Everything about this. Studying aerospace engineering, you don't really get to lick the air to tell the difference of, is it turbulent versus laminar flow? So, one salt versus another purely by taste sounds a delightful way to measure things.
Well, dealing also with impact experiments and all, let me encourage you to stick your tongue out in that flow and see what happens.
I will.
So related, in paleontology, you actually will occasionally lick things to find out if it's fossilized or if it's bone. Because if you lick a piece of possibly fossilized bone, it sticks to your tongue. Or of just bone, it sticks to your tongue because it has vesicles in it, and it'll create a little suction. If it's fossilized, it will not, because it's all of those air pockets are filled in. However, we do not do this with recent corpses. Like, no licking the fleshy corpses, please. Yes, Tori.
You're pretty sure it's bone if it's fresh, right?
Yeah, you know it's not. It's not fossilized.
I guess it could be a rock, but then you'd have to know, how did it get in there?
Yeah, and then you've got a whole other forensics experiment going on.
I actually had a question for Scott. Why do you, if you're just checking for grittiness, why don't you just like touch it with your fingers? Why do you lick it?
Well, your tongue's more sensitive usually, and that's what the books tell the undergrads to do.
And your teeth are surprisingly sensitive to the difference between siltstone and a sandstone as well. You don't want to rub it against your teeth hard because you don't want to abrade your teeth, but you can almost immediately, even without training, if you rub a piece of sandstone or siltstone against your teeth, you'll know whether it's sandstone because it'll feel entirely different.
Is this why all us geologists have bad teeth? Oh.
So has this ever gone horribly wrong? Because I feel like we might need to put out a PSA around now to maybe not lick all rocks.
Geologists also carry these. We really do. I don't have anything in here because I had to walk into a downtown Atlanta hotel, but this normally, it normally isn't marked, as I'm sure you would insist it be marked, with a thing called HCl. Because a much better way, but we carry it around our pocket. It's going to rub off. But we always have. There are three things we always have somewhere. We have hammers. We have hand lenses as jeweler's loops, and we have acid bottles. We really do. And if you have hydrochloric acid in this, which is much more useful to distinguish a number of minerals than tasting them. You go around dropping little bits of hydrochloric acid on things, and despite insistence on saying, "Hey, this needs to be dilute," we don't do that. It's much more impressive when things effervesce or fizz vigorously. And so if you do that, and then somebody comes along later and says, "Oh, is this piece of limestone or calcite salt?" and they want to decide how to do that by licking, well, then they're going to have a little bit of a burned tongue, and then it's then useless to try to distinguish anything else later.
I have a really very wonderful segue from this conversation, if I'm allowed to steer in a fun direction.
No fun.
No fun at all. No fun in science. So we did a science demonstration last year for DragonCon. So we did virtual, and the studio where we make Midnight Science Club, we get to do crazy dangerous science demonstrations that we can't do at the con. So we did something that we call ghostly smoke, and it's a demonstration of chemical reactions happening in the air. Because typically if you're learning chemistry, you're like, pour one thing into one beaker and then pour some more in, and chemistry happens. But chemistry is happening in the air too. So we use two highly volatile materials. One is hydrochloric acid, and the other is ammonium hydroxide. So they're both liquids that are very volatile, and they create smoke. And the ammonium hydroxide stinks very badly. So we could not bring those things to DragonCon. But what's really interesting about it is if you kind of uncover two containers of it and then slowly move them together, they start forming a chemical reaction in the air that makes this white powdery smoke material that just sort of appears in the air, and it gets stronger the closer you get the two things together, and then weaker the further apart they get. It's kind of a fun analog for like a nuclear reactor as you like insert and remove stuff to see how much the reaction happens. But the byproduct in the middle is ammonium chloride salt. At first I was like, oh God, don't lick that. That's probably bad. But it turns out that it's also known as something called sal ammoniac or salamac, and it's used in licorice in Nordic countries. They have like a salty licorice, and they specifically use the ammonium chloride salt. So salty things and hydrochloric acid, turns out you can do a really cool science demonstration with that stuff too. That you cannot lick parts of it, but you can lick some parts of it.
That's the fun thing about organic chemistry. A lot of it you should not lick under any circumstance, but a lot of the I'm going to go with most artificial sweeteners were discovered through either bad lab practice or poor hearing miscommunications, because a lot of them are, you get something on your hands because you're not wearing gloves or you're not careful with your gloves, and you accidentally transfer it to your mouth and go, why does everything taste really sweet? And so that's like most of the artificial ones out there. And at least one of them, and I had heard this as a grad student, like I heard this, sort of passed down wisdom, and I was kind of like, is that real? And I went and checked online. This is absolutely true. is that some, PI had told his postdocs, I want you to, test these compounds. And the postdoc heard, taste these compounds. No. Luckily, they turned out to be a good artificial sweetener and not any of the other terrible things you might have put in your mouth in OChem, because there's a lot of bad things. Yeah, but and food chemistry, of course, which is not my bailiwick, but I do love to cook. Stay tuned for our next panel, and that's all artificial, flavors and stuff, and that's all organic chemistry you can and should lick.
While you're talking about sweeteners, I would just point out that I'm imagining that most of you who still have good teeth because you haven't gone around licking and tasting rocks, like this stuff called chewing gum. And if you ever have opened a wrapper of chewing gum, then I promise you that whether you intended to or not, you have eaten rock. Because that powder that keeps your gum from sticking to the wrapper is ground up calcium carbonate, limestone, or marble. Actually, a good deal of it marble from the state.
That's really cool.
So, speaking of sweeteners, Emily, I believe you have something you'd like to tell us about honey.
I apologize for those of you who are slightly hungover and for whom this is going to completely horrify. But so I started out by saying you should not lick the forensic science, which you shouldn't. Please don't lick any corpses you find. However, there is a huge history of consuming mummies. Has anyone ever wanted like a breakfast mummy? Like a breakfast burrito, wrap it up in some resin. Hi, Tori. But here's the thing. So a lot of mummies were preserved in resins or they were preserved in honey. Honey is an amazing preservative. It inhibits bacterial growth, so you don't get the mold on the outside of your mummy, on the outside of your corpse. It actually creates an anoxic environment so that they're not desiccating as much. You get these nice, like fleshy looking mummies. They still look pretty nice and squishy. I told you, you're not going to want to hear this if you're hungover. But when the Victorians, because the Victorians ruined everything, when the Victorians started excavating Egyptian ruins, Egyptian burial complexes, Egyptian mummies, there was a misinterpretation with an assumption that mummies were a powerful cure-all. So there became a very, very lucrative trade in powdering mummies and then selling them in apothecaries in Europe, that you would eat mummies because you had a stomach ache or because you weren't feeling well or because you had cancer. So mummies have been consumed for a very, very long time. And in Chinese medicine, there was a different kind of mummy, which is a honey mummy. They would actually preserve the corpses in liquid honey to the point that it would be squishy, like I guess almost a jerky, and then you would use that as a medicine. So the idea that you're consuming dead corpses is very powerful throughout history, and basically every culture at some point has gone, how do I make myself better? I eat this dead person. And additionally, as our artist knows, mumia was also used as paint. So not only were they consuming mummy directly, they were probably licking their paintbrushes and consuming the mumia that way because it made a beautiful, beautiful brown paint. So don't paint with your mummies either.
Which is better or worse, the radium girls with licking their paintbrushes or the people licking their mummy paintbrushes?
The mummy paintbrushes are much, much safer. Again, because these are preserved bodies, preserved in resin, preserved in salts, it's a process you can actually replicate by using either fruit or gummy bears. And you can actually create like a 1-to-1 ratio of baking soda, salt, sugar, and preserve gummy bears that way, so you get a nice little desiccated gummy bear corpse after a couple weeks. And you can use honey to preserve apples in that way. So you mix honey with, I think it's a 1-to-1 ratio of honey and a salt, preferably a salt that's safe to have in your house. And you can actually preserve apples that way after a couple weeks. It's a fun little demonstration to do at home if you're bored and like to horrify your roommates.
How do the apples taste?
They actually taste very. I have eaten both the mummified gummy bears and the mummified apples. The mummified apples actually taste pretty good because it's salt and it's honey and it's just a little bit of fruit flavor. So think like a freeze dried apple with some honey in it. The gummy bears do not taste as good because they sometimes liquefy, so you end up with like this the gummy bear color has seeped out into the baking soda and salt. And then the salt has seeped in, and I watched so many children eat their mummified gummies and go, why did I do that? But at that point, they are just way too late, and they have committed.
So speaking of horrifying things, is there anything that would be really tempting or look good to lick but would be a really bad idea?
I'm reminded of, sadly, Mika McKinnon is not here with us, but she does a Twitter series called You Find a Rock, where she then, posts a cool picture of a rock and has people comment on it, and a lot of them are about, like, licking it, and then she'll be like, well, you answer the poll, lick, smash, zap, pet, and the poll is lick, and she goes, well, you licked it. You're in the hospital now.
And unfortunately, a lot of the crystals that look real tasty to lick, like the bright colored ones that look like rock candy, are the ones that are going to put you in the hospital. So they really are forbidden candy.
And if I can get serious for a moment with sort of a PSA, we actually have a real problem in this state. In the southern part of the state, there's this wonderful rock made mostly of mineral called kaolinite. You know it as the stuff you write on, right? People think you're writing on paper. You're not writing on paper. You're writing on clay. And that really glossy stuff, glossy papers, the kaolin in Georgia is what you're writing on because it's very, very pure. That's good, but it's still got a lot of stuff in it, and people like eating it to settle their stomachs. And famously, the kaopectate has that KO in it because of the kaolinite. It doesn't have it in it now. For very good reasons. But I could make a list as long as this room of bad things and reasons not to eat it. But the two you seldom actually see in lists. I was looking this up right beforehand just to see, if you go Google this, what are the problems with eating rock? They actually don't list two of the major issues, which is, even though it's really pure, it has little teeny tiny grains of quartz in it. If you ever ingest anything that has little teeny tiny bits of quartz, you really wish they had bigger grit, because the little teeny tiny ones act like tiny little scalpels when they hit your tissue at the cellular level, and they will cause mutations to give you cancer. And the other thing is, these rocks are forming out of what was mud on seacoast with a lot of ocean water. And the concentration of a little compound called uranyl in ocean water is relatively high. That's uranium oxide. And so if you consume this a lot, more than just say, hey, let me taste a rock, it really causes a problem.
And related, who here has had like the goth lemonade or the super black ice cream? Anyone? I've tried the black lemonade. It has activated charcoal in it, which is a really, really popular health thing. Like, it's sold everywhere to like detoxify your body. Your body's real good at detoxifying. Like, it's made to do that. Unfortunately, with this popularity of activated charcoal in food, approximately 40% of the population has at some point been on a medicine that activated charcoal makes stop working. It's birth control. So you really do want to be careful with some of these things that are considered natural, healthy, safe ingredients, because if you are eating something with activated charcoal in it, then taking your birth control pill, you have just made your birth control pill not work at all. And that is also true, I think, for some of the heart murmur medicines. I can't remember which one, and I had trouble looking it up this morning. But yeah, be very careful with charcoal-containing things. You can still use it in your toothpaste, just don't eat your toothpaste.
I think it's probably a good time for some Q&A. I don't see the person who is going to run the mic. Oh, there you are. Okay. So if you could just raise your hand quietly. I believe in the front.
You know, it's all just you should, you shouldn't lick the science. Is there anything that you just physically can't lick?
The moon.
Well, I mean, not directly, but I mean, I can lick moon rocks.
True. So yes, you can lick the moon.
Yes, you can. I mean,
The Smithsonian really doesn't like that, though. You'll get kicked out. What would moon rocks taste like?
dirt.
We do know the moon smells like spent gunpowder. All the astronauts who've been there were pretty clear on that sort of like weird gunpowder thing. Is it Jack Schmidt who was allergic to the moon? One of them was allergic to moon dust, which is a really exciting allergy and a really weird one to find out. Or
I
like,
don't think Jack is. I think we actually had Dave Scott's suit for a while. I think he had an issue. But yeah, I mean, it's basically, if you want to know what the moon's made of, just go to Hawaii or any place with a basalt flow, and that's the Maria, that's the dark part. And the white part is basically plagioclase feldspar, which is, I mean, that's kind of the white part of even a granite. So again, it's kind of dirt.
Have you ever had a time where lick the science quickly became don't lick the science?
Well, I have done, I did one archaeological dig that happened to be in a previous field that had been used for sheep. So you want to taste the bone to see if it's, because this was about, I think it was about a 10,000, it was while I was in school, so 20 years ago. I was about a 10,000-year-old, so it's the edge of, could be fossilized, could just be skeletal matter. However, you don't want to lick anything from a sheep field because scabies is which is basically the sheep equivalent of mad cow. So don't lick anything from a sheep field, no matter how tempting that femur is to lick.
Talking of health fads that are actually very unhealthy and a bad idea, there has historically been a history of, I forget exactly when, people eating radium for what they thought was health reasons. And I wondered about your reaction with the history of that, particularly as now there is a new fad for some, I forget where, people are doing that. They're going to a formerly radioactive site and drinking the water. I don't know if anyone's heard about that.
Yeah, that's kind of been a consistent problem from about the 50s on. It goes in and out of fashion for the health community. It tends to be very, very low radioactive water. It's not super dangerous. It's mostly actually a scam. They claim it's radioactive water, and it's actually not. So, like, either you are consuming just water, like, oh, here's your radioactive Dasani, give me $50, or you are consuming radioactive water. It's not going to help you. It's possibly going to hurt you. Don't do it.
Besides something like molecular gastronomy, what would you call the best science to lick?
What's that next panel again?
fantastic yeasts and where to find them.
I really like licking yeasts. I like bread.
I don't like licking yeasts directly. Like, I have to admit, what I like is, bread, beer, kombucha, that kind of thing.
Hot
Well, no, I
yeast
don't like
farts.
kombucha.
Yeah, hot yeast farts. That's the good stuff.
Yeah. Or you can get ice cold chilled yeast in the off on the Hilton patio. Drink it in a nice solo cup.
The really we're talking about the moon, and the really kind of irritating thing for geologists who like licking and eating rocks is on this planet you have to deal with that organic stuff that's pretty much crusted on the top of everything. So even if we could find beneficial reasons to lick the rock other than just to suit our fancy, then we still have to deal with that. But If I might, it's funny when you brought up the moon rock thing. I really didn't have. I had a couple of samples here for this panel, but I had a couple of samples for a panel later in the afternoon. But I actually do have. I don't have a piece of the moon, but I do have a piece of the core of a planet. And I do have a carbonaceous meteorite that's like the most primitive stuff in the solar system. So, if I wanted to lick those, I could actually, lick the very beginning of the solar system. And you want me to do that? Would you care to guess what it tasted like? Dirt. Now, I'm not going to lick this one because this is iron, but it is kind of neat that that organic crust I was talking about. Have this little virus thing traveling around and all, and worry about that. This is actually pretty good because a lot of these metals like this, particularly some of the more exotic ones, the residence time of that virus, at least my understanding is very short.
All right.
So a popular way to see if 9-volt batteries has charge is to, of course. Is there any problems with licking such a thing?
So my father. So I have a good. I need to preface this story with I have a good dad. He's great. I love him to pieces. He's a great dad, but he's a dad. So 9-volt battery. They mostly don't, but at some point 9-volt batteries used to come with a little bit of red wax on the top. And Dad hands me I'm fairly young, 9, 10, somewhere in that range. Dad hands me a 9-volt battery, and informs me that it tastes like cherry. So I lick it like you lick a lollipop. It does not taste like cherry. It tastes like betrayal and pain. What you're supposed to do is very quickly touch it to your tongue, and if you feel the shock, then that means there's still juice in the battery. But Dad didn't tell me to do that. I'm fine. There was no damage.
As far as danger from that is concerned, I mean, 9 volts not going to really hurt you, but any time that the juice in there starts getting anything higher than a 9-volt battery, I would dissuade anyone from licking the terminals that come into your house or something like that.
Okay, so online I've seen people licking salt lamps, and as you said, because they're pinkish colored, and you said that usually the colored rocks are the ones you don't want to lick. So does that have any bad effect?
Well,
So you're talking about the Himalayan salt stuff.
Yeah.
I mean that pink color is largely an indication that there's more sylvite, which is the potassium chloride, as opposed to the sodium chloride, but they're mixed. So typical rock salts are both. But no, I mean that part's not going to hurt you.
Yeah.
The potassium chloride doesn't actually hurt you. It just tastes not as good as regular salt.
And where you really want to start to get worried about licking things is liquid salt licks. So if you're looking at a liquid salt deposit rather than a crystal salt deposit, you can get some pretty nasty microbial organisms, some extremophiles that actually really, really love living in a super briny solution. So if you have a bright red salt lick, it could be rust, it could be fine, but it could be a microbial organism. Maybe don't stick your face in the salt lick. And for those of you who don't know what that is, I'm not referring to the things you buy to lure deer. I'm thinking of where salt bubbles up from the ground. I'm from Cincinnati, in Kentucky. There's a lot of salt licks where there's these places where salt bubbles up and you get lots of animal preservation. Most of those don't have microbial communities, so you can actually lick the mastodon bones you find there. But it's not really recommended because we kind of want to know what microbes are on those bones before you lick it. You don't want to contaminate your science.
And it's a really good idea. I mean, just to keep in mind that the processing that our materials go through before they end up in foods is kind of deliberate and important, even for things as simple as salt. I mean, those salt deposits mostly are from evaporated seawater. And so things that don't, evaporate get left behind as various minerals. So if you want to go looking for some pretty nasty stuff, look at trace amounts in just about any rock salt, and you're going to find it, along with the fact that those alkali metals and potassium, sodium that go with the chlorine, other things in that part of the periodic table will get together with chlorine too, like lithium and going out and getting a rock and licking it once or twice, no big deal. but you don't want to make a habit of that. You don't want to consume your life's amount of salt by getting natural rock salt. Have it processed safely.
You know, this actually kind of makes me think, and I sort of have a question for you guys. Part of the reason we know all this stuff about what does all this stuff taste like is because there were scientists that came hundreds of years before us, before they have all the tools and measurement equipment that we have today, that was the only way they could figure out what they had. And I think it's really interesting to me that there were people who were willing to just lick stuff and figure out if it was going to kill them or not. And that somebody would do that for science. But I mean, you guys, I think, have a stronger background in the chemistry. Do you know much about what the transition was like as they slowly developed the tools to no longer need to lick everything?
I mean, so I give my students a list of lab safety instructions, and I didn't write it. It's been handed down for at least a couple generations worth of science teachers, and it still says do not pipette by mouth, because they're used to so when you're pipetting, you use a big rubber squeeze belt to suck liquid up and squeeze it back out. But you used to just suck on it like you suck on a straw and try not to get it in your mouth too much. And that instruction, still exists within living memory. Like my previous department chair would say, "Oh yeah, no, we used to mouth pipette all the time," and I was like, "Karen," she wasn't that kind of Karen, but her name was legit Karen, and I would say, be like, "Karen, are you okay?" She's enjoying her retirement. It's cool. A lot of that sort of history warning still kind of lingers because, while science is about change, it's also about keeping our history. And so you have that sort of leftover there. And I always tell my students, just don't put anything in your mouth in this class. Just nothing in your mouth while we're in chem lab. Yeah. I did once, sorry, go ahead.
Oh, no, you can continue.
Oh, well, I have a slightly related story. So I was doing a demonstration in my lecture classroom that involves corn syrup. It's a really cool demonstration of polarized light. So corn syrup contains a lot of chiral molecules that will rotate polarized light. The glucose in it will take light or sucrose, will take light and actually twist it. So you set up a thing with some polarized filters and you shine. It's the only time I ever use an overhead projector is to do this demonstration. Because, what am I going to use that for? It's 2021.
Archaic technology, like mouth pipetting.
Exactly. But it's a great lamp. So you shine it up and you do some cool tricks with polarized light. So I've got a beaker. And I'm pouring my corn syrup. It's a fresh bottle of corn syrup. Pouring it in there. There's a drip off the end of it. And without thinking, just like you do in the kitchen. So I just wiped the edge of it and stuck my finger right in my mouth. And one of my students goes, "Did you just lick it?" And I kind of go, "No." Because, obviously I had. What was I going to do? So I'm like, "Nope." And then went on with the demonstration. It was pretty good. So even though I know I'm not, I was in a classroom and it was a brand new bottle. I was not actually in danger, but it's an easy habit to get into of you just lick stuff.
Well, related to the transition of scientific methods, the interesting thing about the archaeology and more osteology-centered anthropology is even in my lifetime, we've transitioned from a lot of not being super careful about handling fossils and bones because there wasn't much we could learn that we would contaminate if we were handling it by hand, to moving to a more molecular DNA-based methods of science. We now, even since I was trained in the early 2000s, we're now very much more careful about handling bone, particularly bone and not fossil, because we want to keep that DNA evidence intact. So you're not ever going to really lick a sample that's going to go into a collection to be studied. You're gonna, if you're even going to lick it, you're gonna lick something small and off to the side so that you are not contaminating your science. Because we really don't need scientist mouth bacteria from 2021 contaminating our 9,000-year-old skeleton that we want to pull DNA evidence from.
I know that a lot of, in the history of mineralogy, I'm not sure where there's a transition, but certainly the recognition of arsenic and the even relatively short-term exposure was a big deal. And, the main thing there is it could have, you pick up in mental effects, but mainly teeth. just like you do with long-term exposure in water. But the other thing I was thinking about, somebody had to be really. I don't know. I wish I knew more about how the transition went with sulfur, because sulfur is something that, depending on how you taste it, can have kind of a good taste, and certainly can go into a lot of into solution, and the things are good. But the easiest way to get sulfur was around volcanic vents. And if you just go up to a volcanic vent that has sulfur around it, and you get the smell and everything, realize that in that same group of minerals that maybe you don't see are little orange specks and red specks, and those are arsenic sulfides and mercury sulfides. And cinnabar, which is really pretty, is if you get a big crystal that's red, you can actually look at it at room temperature and start to see little beads of mercury form. And I'm sure there were people who consumed that.
Yeah, and like identifying pyrite, fool's gold. Get a little bit of saliva on your finger and rub it, and then smell it, and you can smell that sulfur egg smell. But you really don't want to be licking the pyrite directly. You're kind of using the acid and the friction to release a little bit of heat. You can do the same thing with amber. You can identify some of the harder amber bits by basically getting a little saliva and a little friction. But you're not going to really learn anything by licking the amber. You're more releasing a scent.
Yeah, the pyrite also has, typically any pyrite has arsenic in it.
Yeah, you don't want to lick pyrite. Just I know it's pretty and shiny and it looks like it tastes good. I'm not saying this from personal experience, I promise. But don't lick it.
All these, when you say not personal experience, I can vouch for. If you want to say something, I can vouch for it. I mean, we do ultimately probably taste the stuff once, at least.
And I worked with small children for a very long time in the museum, so all of my rock samples have been licked by children, which is also why you don't want to lick the science, because that 5-year-old has already been like, ooh, science, yum.
So my personal science, you definitely don't want to lick. I'm a microbiologist, but there is a field that is in my building that you have to lick, and in case you actually have to eat. The FDA does organoleptics, which is they have calibrated noses and calibrated mouths to detect seafood decomposition. So if you go on the FDA site, you search organoleptic, you'll see, you have to describe things as bilgy or salty or, musky, things like that. So, because that's the most sensitive thing and it's the cheapest thing to do. So is there anything that you have to lick, but you really don't want to?
I mean, again, that food chemistry, sometimes, you find out that your food has gone bad by tasting it. And as you say, humans are really sensitive to things like spoiled milk or spoiled fish or something, because, that's going to mess you up pretty quick. So you notice that real fast. But I don't know that you have to lick it. Preferably you catch it by smell, and they're like, I'm gonna not eat that.
Though, interestingly, some of the things that convince humans they don't want to eat something, say the rotting fruit smell, where you smell, we're very good at detecting the smell of rotting fruit as humans. So you smell that and go, oh, I don't want to eat that. However, animals that grow up that evolved in an area of low resources, particularly desert animals like tortoises, they actually learn to be very good at sensing that smell and going towards it, because that is a high calorie thing in a resource low environment, and they've evolved to not be damaged by that rotting fruit. Unfortunately, that has an interesting side effect, that tortoises tend to love bleach because it puts out the same scent. So if you bleach your tortoise's room and then put the tortoise back in it, it will lay in the center of the room and go, so good, so good.
In terms of like a job where you have to eat things, I always wonder, for those people that make, if it's edible cosmetics or if it's any of those things that are like, hey, you can eat this, but it's not really food. Somebody's job is to taste that, right? To figure out if it's good or not, if it's bad. But I guess that would be somebody's job, where it's like, yes, this lubricant does taste good, I guess, but I don't know whose job it is to do that, but I don't envy them.
So my previous next door neighbor actually is a super taster and a super smeller, and he actually his job was to taste things for artificial flavoring company for artificial flavoring for foods, for medicines, for anything like that, and say, will this taste good to the majority of the humans? Will this not? He also was a trained chemist, so he had that chemistry background and that super tasting, and he was apparently very, very good at his job.
So I'm sure you all are familiar with the practice of tasting urine to diagnose diabetes. I was curious if you knew of any other kind of like practices in medicine that involve tasting to help diagnose something.
The closest thing I can think of is there is not tasting but smell. That is it. I think it's when your liver stops working, your breath. Say again. Kidney failure. And what's the smell? Yeah, you end up with really bad breath. So I know that in medicine, which is science as well, that there are also diagnostic techniques of like, oh, this open wound smells like almonds, therefore gangrene, right?
And I believe there's also a if you get certain kinds of tooth decay, you taste differently. So you'll be asked like, is one of your symptoms a weird sense of taste?
Yeah.
There's a certain infection that you lose the sense of taste and smell.
I have no clue what you're talking about.
Okay, so for something that I guess it's a little beyond taste and more like ingesting. So I guess along the lines of activated charcoal and the radioactive water, but on a much more serious level, like lithium. How did people decide? Like what was the process in that of like, oh yeah, so we're actually going to give this to people to help them, but also like, how did they weigh the benefits to the like, oh god, this could like really destroy your body?
So back to the Victorians, if you look at the history of every single medicine used then, it is absolutely horrifying. These were human experiments with no understanding of experimenting. They're just like, we can't cure this any other way. Try this thing that has some intense other effect, whether that's making you puke, making you sweat, making your personality change. The assumption was if it was having a strong effect in one area, it would have a strong effect in other areas. And some of those turned out to work pretty well, or not terribly. But it really was this giant experiment on a society-wide scale of, well, does this kill more people than it cures? Does it cure more people than it kills? And also a lot of things that just didn't work, like the cure for migraines, where you would cut a toad in half and preserve it in honey and stick it on your forehead. Doesn't work. Probably made people puke though, so had a strong effect, doesn't actually help migraines, though.
I feel like oftentimes in medicine, there's always sort of that balance of, we know it has X beneficial effect, but it also has this list of side effects. And I think there's always a desire to get that list of side effects as short as possible, but it ends up becoming a pros and cons situation. I think people still take lithium because it's still a very powerful mood-changing drug, even though it's horrible for your liver. And so it kind of becomes are you going to live a more miserable life without the lithium versus are you willing to shorten your lifespan by damaging your liver by taking it? And I think that's one of those really difficult, ethical, hard things that I'm glad that I'm not a doctor having to make those kinds of decisions. But I think that in science and everything we do, that's always a very core aspect, like how much of what we're doing is helping versus hurting, and can we make that as much helping as possible?
So I'm sure you're all familiar with the film trope of the hard-nosed detective who tastes the white powder to tell if it's cocaine or something. Do any of you have any favorite gripes about other things you have seen in film or television where somebody tasted something? We're like, no, don't taste that.
As the forensic anthropologist, every time someone sticks their finger in the crime scene, sticks their mouth in the crime scene, puts their ear to it, you are contaminating your evidence. Don't lick, smell, hear, touch, rub your face up against the crime scene. Please. Sorry, I have a issue with an entire genre of TV. Thank you. Don't get me started on Bones. I love it. I watch so much of it. I can't stop. But also, speaking of licking the science, Bones had a really great episode on corpse preservation where they completely messed up the science. So there was an episode, I think in like the second season of Bones, where they found a corpse inside a chocolate, inside of a large piece of chocolate. They went for the punchline of chocolate with a gooey center. However, chocolate will preserve corpses. It has high sugar content. It has high, it inhibits microbial communities, and it will actually preserve it in like a nice gooey state. So you can get that soft tissue preservation. So Bones completely messed up being able to have like a really cool corpse preserved in chocolate by going for a silly gooey center joke. What? Even with a really high temperature. In fact, really high temperatures are great for within limits. You don't want to incinerate your flesh, but the temperature that you're cooking chocolate at is basically going to kill everything that would dissolve your body. So you're actually creating very, very good temperature stable preservation methods because you're not actually getting to the point where you're incinerating the flesh like in a Pompeii mummy. However, it's hot enough that it's going to instantly make you into human chocolate beef jerky. So you actually would even be able to probably preserve fingerprints in that chocolate shell. Yeah, it would be really, really cool. I don't know that this has ever happened in history, and I'm not going to go do that experiment because I can't get approval. But it's a really neat process.
I feel like everything I'm learning is interesting ways that I could be buried. Just brick of chocolate in the ground.
I'm also realizing if she ever opens a restaurant.
I regularly do a panel called How to Get Away with Murder. So there are recordings of it. One of our other science track panelists, Rachel Burks, is a forensic chemist. So look up Rachel and her work with the Chemistry Society. She's done a lot of videos on how to dissolve corpses, how to preserve them. They are horrifying and disgusting and wonderful, and you'll love them.
PSA, don't do any of that. Except look them up. Yeah. Also, I think we have time for about 2 more questions.
So back before we knew what radiation and uranium and all that stuff is, they used to put uranium in glass. It was called uranium glass, and they would like drink out of it. So like, is there anything that we use to eat stuff that we probably shouldn't be using to eat stuff?
So, do you want to take this?
I was just gonna say the radioactive Fiestaware that your parents might have had, or grandparents. I don't know what the age range is on that anymore. But that bright red Fiestaware has pretty much all been retired, and you can't even usually find it in antique shops anymore. Like they've done a modern colorway of it that is not radiation. I think it was uranium that was in that. So you can get that. But I honestly I don't think uranium glass is going to kill you if you collect it.
Yeah.
But I probably wouldn't eat out of it every day. Like that feels a little risky.
So with uranium glass, part of it is you can consume things that have not been sitting in uranium glass. And this is the same thing with leaded crystal. You do not really want to have high alcohol content in leaded crystal for a long time. So like my parents had a bottle of, please don't judge them or us. It was their young 70s wedding. They had a bottle of Southern Comfort in a crystal decanter that they had had for 20 years. And then I come home from college and look at it and go, wait, that is very nice crystal. That's very nice leaded crystal that you have had alcohol seeping into. And they used to like do a shot occasionally on their wedding anniversary. Seal knows my parents, so she knows that this is one of the only alcohols they drink all year. I had to make them pour it out because so much of that lead would have seeped out of that decanter and into the alcohol. So it's okay to keep it in for, like, pour your bourbon into the decanter for a night, for a nice party where you want a pretty presentation. Don't keep it in long term. Or if you're going to, do it in a glass decanter, not the pretty crystal decanter. But also uranium glass, you want to avoid, you don't want to heat it up with food in it. That's one of the main problems. You can put food in it, you can eat off of it. You don't want to do it every day, and you want to generally stick with cold foods and foods that are not going to be particularly corrosive. Now, another interesting antique show find is books, ancient old books from like the early 1900s. If they're dark green, they almost certainly use arsenic in that color. So you can have them, you can keep them. You don't really want to handle them. You don't want them within children's reach where they can lick them. Please don't lick the antique books. I collect those books, but I have them behind glass in a locking cabinet. So they're not contaminating the air. I'm not holding them. My niece can't get to them. So that is a very serious, like, be careful about green antiques. Don't lick the old books and do not speak Latin around them.
I'm, thinking about modern day examples. I'm thinking of, like, as we're slowly figuring out, like, the hormones that are in a lot of plastics. And, I'm not super up to speed on everything, but that's why they wanted to get BPA out of everything. Was we realized there was this additive that we were using in plastics manufacturing that was not good for us to be consuming. And I'm sure there's more of that we're going to discover over the years where they figure out, oh, this salt additive we're using or this artificial sweetener, turns out that builds up in your kidneys over time or something like that. And science is an ongoing process. It turns out our bodies are pretty good at filtering out a lot of garbage, but the more garbage we can stop putting in is always a good thing.
In general, you don't want to microwave food in plastic because there is a surprising amount of leaching. It's also dose dependent, so doing it every now and then is fine, but don't put your food in your Gladware and then microwave it in there. Move it to a ceramic dish, move it to a glass microwave safe dish, something like that.
So, prefacing this with, I just read The Demon in the Freezer by Richard Preston, and in it, Lisa Hensley is in BSL 4 level lab with her mentor, and her mentor's arm goes slack. She thinks he's got a stroke, and it turns out he's just eating a candy bar in a BSL 4 level lab. So have you had any instances of something like you're not supposed to lick the science in the science turning out really, maybe, I don't know, dodging a bullet kind of thing?
So I managed to give myself arsenic exposure. I am not allowed to work with arsenic, by the way. I am not a molecular person for a reason. Give me a hammer and a computer. Maybe a shovel, maybe a brush. But I worked at a museum that had a lot of old taxidermy mounts. Taxidermy mounts from before 1950 were often preserved with arsenic, and I was cleaning out a closet where we had some old duck and surprisingly a golden eagle mount. That was a fun discussion with the USDA and licensing. But I handled those. All I did was I picked up those mounts, moved them out of the closet to clean, put them back. About a half an hour later, I started sweating profusely, flushed completely red, and had a copper, like a weird metallic taste in my mouth. Luckily, one of the maintenance guys walks by and is like, "You don't look so good." I'm like, I feel really funny, and he goes, "What does your mouth taste like?" Like metal. He's like, "Oh, that's arsenic. Please go walk away." Now, luckily, these were not super contaminated. It was a fairly low dose. But yeah, you have to be careful with particularly old collections where you've lost the trail of evidence. You don't necessarily know what they are. But yeah, I managed to give myself arsenic exposure. You wait. You wait. It was clearly not a dangerous level. It was a very mild exposure, and one of my coworkers always so had it. We actually sat through a meeting while sweating profusely with our new curator.
If there was ever an excuse to miss a meeting,
Look, when you're meeting the new curator, you do not miss that. But we had a very close relationship with our local like poison control, and because I worked. Welcome to Museum Storytelling with Emily. So we called and we're like, these are our symptoms. This was our level of exposure. They're like, just wait it out. It's fine. We don't think you had a dangerous exposure level. Had it been any worse, they would have sent us to the ER pretty much immediately. But we were advised by actual medical professionals that we were going to be super uncomfortable for a little bit. And that I think we were not supposed to drink milk. Like, because the milk would pull, I don't know for sure what it was, but I think the milk was going to bind with the arsenic somehow, and then that could get pulled into our bones. So we were supposed to just not drink anything during that time and wait it out while it evacuated our system.
The only thing there are a number of things, like I said, I mean, we eat rocks, so what do you expect? And we probably have had those exposures and never even known it. There was a time back when I was in undergrad at Arizona State, and I was in a chemistry class, and this is one of those taste/smell deals, but we were doing some simple things, supposed to be, and it involved heating a sulfurous compound, which will produce sulfur dioxide, which will come off and go into the air. And you know that if that sulfur dioxide, you kind of have a reaction to get away from it. And even worse, if it combines with hydrogen to make hydrogen sulfide, you even have a even more smell issue. There is a little bit of material, though, that if it encounters enough water vapor, can actually convert to sulfur trioxide, which we can't detect until it hits a membrane. And so I created inadvertently a little cloud of sulfur trioxide that traveled along a little ways. And I then happened to put my face too far into the hood. And there was no sulfur dioxide or hydrogen sulfide rotten egg smell. It was just suddenly pain. And that took a little, it was a pain for a while. But then, to tell you how smart geologists are, a year later, I was actually in Hawaii out working on lava flows, and my advisor said, go out there, and this is where the lava empties into the ocean. You get this big steam plume. To go out there and just look and take photos and everything. But he didn't come with me. He said, just go out there. And so I go out. There are plenty of tourists around too, but I'm going out at night, and it was really pretty. But standing there, I should have remembered a year earlier with the same lab, because the same thing's happening in that plume, except now you've got sulfur dioxide, sulfur trioxide, hydrochloric acid, and unimaginable numbers of other things that do the same thing. So you suddenly ingest that. It's come to think of it, it tastes really weird, but then that is followed by pain.
All right, we're pretty much at time. I just want to go down the line if you have any final thoughts, and where can people find you after this?
I think ultimately the guidance is don't lick it if you don't know what it is. I am Nick Householder. If you want to see what I'm working on nowadays, check out Midnight Science Club. We're on YouTube. We got a lot of stuff on TikTok, Instagram, everywhere. We do cool science demonstrations, and we're working on a series called Maker Science, where we go out and meet up with cool people who build and make things and talk about the science behind what they're doing.
And I'm Emily Finke. You can see me next at 4 o'clock in this room for Making Were Creatures, where we will take completely absurd creatures and figure out the implications of making, say, a were-wombat. How is that going to work? You can find me as Celix on most social media, and I primarily hang out a lot in the DragonCon official Discord and Science Track, where we discuss at length why you shouldn't lick lava. So join us there.
We spent like 2 days on whether or not you can lick the lava.
It was 72 full hours.
My opinion is, as a chemist, lava is not wet because it doesn't contain any water. But that doesn't tell you whether or not you should lick it, just that it's not wet, despite being molten. I am Tori Stenmark. You can find me, most of my science crap posting happens on Twitter as Tereshkova2001. My cosplay stuff is on Instagram. I will be on the very next panel, Fantastic Yeasts and Where to Find Them. And also tonight, Color, Light, and Photography, where we're going to talk about costumes and fabric, or I'm going to talk about costumes and fabric. Yeah. I like your advice. Only lick it if you know for sure you should lick it.
And I'm Scott Harris. Again, I am the planetary geologist for Fernbank Science Center and the Jim Cherry Memorial Planetarium down the street. I wished I could invite everybody down for the planetarium, but we happen to be one of the huge planetariums in the country, but the only one owned by a public school system. So with a resident student population, so until all this craziness gets done, we're not open to the public. But that forced me 18 months ago to take our entire operations online. So if you want to go to Fernbank, it's www.facebook.com, Fernbank Center. I host a twice weekly Friday evening and Saturday afternoon live broadcast out to the world. And it started off with this modest thing, and now it's gotten out of hand. And we get not only space and earth science people, but I actually got a commitment from one of the guys who invented lithium batteries to come on in October. So check us out there. There are already 180 or so things. If you anything about, particularly again, space and earth science, it's there.
All right. Well, thank you everyone for coming.
All right, folks, that was Please Don't Let the Science. Next in the room, we'll have Fantastic Yeast and Where to Find Them. We will clear the panel room beforehand. Let you know we do have science track ribbons if you want science track ribbons. We are offering, if you want to upgrade to the NK95 mask, we can do that as well. Also, if you want to donate to the Big Brothers Big Sisters of Metro Atlanta, we'd be very grateful of you for doing so.